Hey, welcome to the Ozzstar's Cars channel. I'm Glenn. Today's fun project, we've got a 2013 Audi S5 here behind me, and the customer complaint is that the air conditioning is not working. So I've already diagnosed this car, and I want to walk you through the steps on how we came to the conclusion of what the problem was here. Now basically you hit the AC button, you've got the fan on, and you're not feeling any cold air. And that's probably due because the compressor's not kicking on. So what I did was hooked up my Autel, this is the MS906BT right here, and I got these two codes, which is the 457 at the top, the electrical system control module. What that means is basically the ECM just reporting there's an issue, an electronic problem. And then the one we're looking at here is the 256, which is the sensor for refrigerant pressure, temperature, implausible signal, so meaning that the ECM is not receiving the signal. Now, what's interesting about this particular sensor is it's a 3-wire, which is standard, and the power, you have power, ground, and then a signal. And normally you would have not normally, but on some older vehicles, you have 5-volt reference. So you're looking from 0 to 5. Well, the issue with this particular car, or not issue, but the technology, is it's actually that signal wire, which I'll show you, I'll take you down here in a second, is a data line. So this data line sends packets, I believe it's the LIN bus, there's CAN bus and LIN bus. LIN bus is a little bit slower. This is the system that would run like your power seats, power windows. I'm told on the Euro cars now that even the water pumps and the electric water pumps and the electric thermostats are all now run with LIN bus. So it's a data packets, and what I'll do, I don't know if you can see right back here is our oscilloscope, and in a couple minutes we'll hook that up and I'll show you how you can see that. Now most people aren't going to have this equipment. They may not even have this fancy scan tool that I just showed you. Maybe you have one of these, a smaller code reader, and I'm not saying that all code readers won't pull those codes that I just showed you, but you may not get any trouble codes. So keep that in mind. If you do get those codes, that's great. If you don't have a set of manifold gauges, which is for your air conditioning pressures, your high and your low, it's going to be part swap-a-roo time, basically, is what it is. So what I want to show you guys right now is maybe you have a manifold set gauge for your air conditioning, maybe you don't, maybe your friend has one you can borrow, but we want to just prove the theory that the first thing you would suspect if your AC wasn't working, that you were low on refrigerant. So here we're going to hook this up here. Let me make sure this is closed and this valve's closed, and once I connect that, we're going to get a shot of these gauges. I want to thank Gilbert's here. He owns the car. He's my camera guy today. So say hello, Gilbert.
Hello, Gilbert.
There you go. So let's hook this up. It's nice having an extra set of hands, that's for sure. And as soon as I connect this, get a shot of these gauges here, we're at 0. This would allow us to verify that we do have pressure. And if you have a bad sensor, basically your scan data is going to show error. It won't show any pressure. So let me open these now, and then you can see these gauges. I'm going to open the low side first, and that we should see that go up. That's called static pressure. And now I'm going to go on the high side. Open that one up. Oop, there we go. So static pressure, basically we're about like 90, which is good. We want to see both of these gauges around static. That means that the compressor's not running, the engine's off. We want to see that, and we know our valve here isn't stuck. But anyway, that's the point is right there. We already know there's pressure in the system. There's enough here that the compressor or that the ECM should be happy to turn on the compressor. So that's it for that. Now when you fire up the car and your compressor's running, on the low side, I'd say you want to be about 25 to 35 psi, and over here on the high, you'd probably, now this depends on temperature and humidity, about 150 to 200 is where that will jump up. So anyway, basically that's what you do here to confirm that you have the proper amount of refrigerant. So I'm going to disconnect this now. Let me shut these off. Make sure that's off. Pop that off. And I'm just going to take this out of our way so we can get to the next step. So what I want to show you now is where the sensor is located if you get that 256 code. So it was 256, yeah. So right down here now on this Audi S5 and a lot of the Volkswagens and Audis, whether, you know, depending on what year and what model, they're all basically going to be in the same location. Some are a little bit easier to get to, some are a little more challenging. Like this one's kind of tight right here. This is the sensor that we're looking at. It's a pressure sensor, and it has a 3-pin. So you have one is power, one pin is ground, and the other one is our signal wire, which is that data link line that the computer is looking at. But anyhow, this is where it's located. Let me show you real quick how to pop that out. So what I do is I take a long flathead screwdriver and some long needle nose, and basically I grab onto the switch, or to the connector, not very hard, just giving it a little bit of squeeze, and I'm pushing in on this tab while I wiggle and pull up, and I made that look easy. So your first time, it probably won't go that slick for you. But anyway, here's our 3 pins, and there's our 3 wire. That's the sensor. Now when you remove this, you take a 24mm socket. Let me grab one. What I have here is, it doesn't have to be an impact, but it's got to be deep, will work better for you. A deep socket. I put an extension on here. This one happens to be 1/2-inch drive, 6-inch. Just slip it right down over top. In fact, let me show you up here. Where's my sensor? So basically what I'm doing is, you might want to pull back just a little bit over this way. So basically this is it. It's going in just like this. And then we're backing this out. This is threaded in here. The line has a male threaded Schrader valve on top. So that actually, this female threads right onto it. The thing that you don't have to worry about is once you remove this, now on some models, not on these Audis, VWs, they have a Schrader valve in it. A Schrader valve is the same valve like when you put air in your tire at the valve stem. So as soon as you remove this, as long as the Schrader valve is working properly, boom, it will hold the refrigerant in for you. You don't have to worry about it, and they don't usually go bad. Okay, so now I want to check for powers and grounds, and I probably should have mentioned this earlier in the video. So you want to check what's called circuit integrity. You want to make sure that whatever sensor or whatever you're trying to power up has power, which in this case is 12-volt battery voltage. And you also want to check the ground. So you want your ground to be as close to 0 as possible. You don't want to see voltage there. That's a good ground. And you want to be, in this case, 12 volts to 14 volts. It depends if the car was running or not. But whatever battery voltage is. So anyhow, we got the 3 wires right down in here. And we don't know right now without a wiring diagram which one's ground, which one's power, which one's signal. So our voltmeter is hooked up. We're on a 20-volt scale. And the first wire I'm going to go here is on the left. I believe that's a black with a white trace on it, from what I can see. Now, as you can see here, we have 11.7, which the ignition's been on for a minute here, so it's a little low, but that's battery voltage. We pull that out. We go to the center. We have 8 volts, okay? So that's interesting. We'll come back to that in a second. And then let's go to the right, or my right, your left, and we're at 0. So 0 on the right here, or your left, what is that, like an orange? Pink, it's hard to see, it's a little bit dirty, but that is our ground. Now we go back to the center and we have this 8.1, 8.2, it's just fluctuating. That is actually our data line, our signal line. So we know that the computer, basically the LIN bus, is sending some kind of signal here. Now this is not an accurate way to read it, because if you have, this happens to be a good switch in here right now, pressure switch, I just let it go. The thing is, if you hook a bad, or you have a bad switch in there, you're pretty much going to get the same voltage. So that's what makes this a little tricky to actually pinpoint what's wrong. Now I like to be 100% sure that I'm not parts changing and throwing the parts cannon at it, but in this case you really can't tell. You have to have an oscilloscope to check the signal. So we want to see those data packs. So next step, I think what we'll do is we'll hook up the oscilloscope and I'll show you that. Something that's important with that signal wire, I mentioned the 8 volts, is if you did not see 8 volts there, which like I said, it doesn't really matter, but it does. If let's say you saw 0 volts or something really low like 2 volts, then you may want to consider checking into the wiring as far as the integrity further, because there could be a cut wire, there could be some corrosion, maybe a rodent chewed through there or something and it's grounding out. So the 8 volts gives you a little bit of information, but it doesn't really determine that the sensor's bad. All right, so I want to mention while we're doing all this, the ignition is on. So you want to definitely, in order to get the 12 volts and that ground to your connector, make sure your ignition's on, the engine's off. So now I want to show you guys how we can prove that the data link is good. Here's my oscilloscope I'm using, and I'm going to back probe. I have my back probe pin here. I'm going, and now the connector is hooked up. I'm pushing down into the center, and we should be getting the signal. So if we come over here, we can see, let me shut the light, we can see the data packets that are being sent and returned. So the computer is definitely functioning. There's no issue there. What this information means, I don't know. I don't know, if this packet says the pressure is this and that packet says the pressure is that, the low pressure, the high pressure. Do not know. All we care about, or we're concerned, is 100% that the circuit integrity is good here. So what I did here was I stopped the, let me show you here. It's running. I froze the, oh, I don't want to do that. Hold on. Let's get this down here. Let's bring our time down. There we go. Okay, so you see these packets right here. That one's too fast. What I'll do is I'll stop this. And now I can kind of zoom in and look at these packets. Let's scroll. And you can see these packets here. There's no, what we're looking for basically to nerd out on this stuff, which is pretty cool if you're into it. We're not seeing any dropouts or any crazy spikes, okay? And this is also, will give you your voltages. But anyhow, there's nothing out of the ordinary here. There's no spiking. There's nothing out of the ordinary that would make me, that's a little, that might just be some noise right there. That's nothing to worry about. If you saw a big spike, then we would probably have a problem. There's a good packet right there. Okay, so I just wanted to explain that and what I'm actually looking for right here. So some folks might be interested in what the actual voltage was here, and we can do that with our scope. So let's go down here. We go on time, and we want to see our low and our high. Okay, and then if you look real close right down here, so the low is 520 millivolts, and the high is 6 volts is where we were going. So that's where we were at. So let's say we saw something crazy here like 10 or 12 or 8 or whatever. We may, well, anything over 8 or 9 we'd probably get suspicious of. So what I want to show you guys, if you're getting these codes and your scan tool can give you live data like this one, we'll see, I'll show you where to go, which would make this diagnostics or diagnosis really fast and easy. So let me go to live data, and that'll pull up in just a second. And then let's go read data by channel. There's different ways you can get to what I'm going to show you, but I know it's channel 1 here just from experience. And right now we have a good switch. Okay, the new one is in, and we're reading refrigerant pressure is 98 psi. So that's almost pretty much what we saw on our gauges. So it's going to bounce around with temperature and heat and stuff. The engine's hot. So anyway, my point is that if you had a bad sensor, your refrigerant pressure right here is going to probably say error. And what we can do is we can get the old switch, which I have, we'll plug it in, and let's see what we get for a reading. By the way, when the compressor is running, the amperage here, this is your amperage, there is a sensor down at the compressor. It's going to tell us what the amperage is here. So we'll start the car up in a minute and you'll see that, but let me grab the bad sensor. What I want to show now is, or demonstrate, if you have live data, this can be pretty simple diagnostics. Here's the old sensor that's bad. We have an error code. I'm going to plug it in. Okay, you saw the good sensor that's down in there reading. So here we are, we're out in the air. We've got an error, it's not reading anything. I'm going to take some compressed air and I'm going to simulate the pressure of the refrigerant. And if this was working, well, we should see something here because the ignition is on. And if you see the screen there, nothing has happened. So let's plug in our, yeah, I'll get it, I'll spit it out. A replacement. This is a new one. I got two new ones here. I got this exclusively for the video because we go all out here on the Ozzstar Cars channel. So I'm about to plug this in. Okay, click. Immediately, it's pulling up 8.7 psi. Now we're at atmospheric pressure. I think it's really like 14.1. I don't know how this thing sees or works, or maybe it's just a Chinesium sensor. I just bought a cheapo one. But this is to prove my point. So if you have a good sensor here and you have live data, you should see voltage right there on the, or I'm sorry, PSI right there on the screen. Now what I'll do is take the compressed air. I'm going to do the same thing. I'm going to try to get it, you know, the same shot for you. When I apply pressure, simulating refrigerant pressure, let's see if that changes. Okay, we definitely are seeing, there goes the compressor. So I jumped up to 50. The number doesn't really matter. What matters is we saw a change. The computer is seeing the sensor, the information, we're good. So that's an important step right there. What I'll do now is I'll just go in the car, I'll start it, I'll turn on the AC, and I'd say we should see this jump up to at least 125 or 150, whatever it's going to be until it builds up pressure. And then we should see amperage here to the compressor. So you keep on filming, I'll do that. Everything's clear of the fan and stuff?
Yeah, we're good.
Turn it off and reset it. I don't think it liked it.
We're plugged in all the way, right? We're good, we got reading.
So that's important to know. What I had to do there was basically shut the ignition off, reset the computer. It wasn't allowing me, you guys couldn't see it. I was pushing the AC button. The red indicator light would not light up. So I shut it off, shut the ignition off and restarted and it reset. And as predicted, we're about 150 or so PSI right now. Here's our amperage to the compressor for the valves to open and close or whatever it needs to do there. And we're all set. So the air conditioning system is blown cold. So if we took a reading right here on the vent, I can feel it. I can feel cold air coming out. I want to clear those codes out right now, so let's go back. Escape out of this. Let's go to trouble codes. I'm not sure if I can reset from there. Let's see here. Clear DTCs. Ignition on, engine off, yes. We'll lose the data, the freeze data, which just means when the issue happened. No fault codes detected. You hit OK. A good idea is to always go back and to make sure those codes are gone, because sometimes if there's an actual real problem, like I believe if the sensor was bad right now, it may throw a code immediately. So you know that everything's looking good here. We click OK and we just escape out of that and we're all set. All right, what I should have told you guys before you get down here to your pressure switch, you're going to have to remove this plastic like cowl cover here. And these things are real simple to take on and off. They just have these little plastic clips and you pop them right out. This one, this particular model only has 4. Done. So let's wrap this one up. If you have a bad switch, you know, the best way to diagnose it, or the most effective way, is to have one of those powerful scan tools. Now, if you don't, keep in mind that a regular little code reader may not give you the codes that we looked up. So like that 256 code. And if that's the case and you don't have a manifold gauge set, then you may not know if it's the low refrigerant. You might not know if it's this. You can start playing the guessing game. I can't figure out any other way to diagnose it other than what we saw there. The voltage drop test doesn't work with the data line that we looked at. So you can try swapping this out, you know, but is your refrigerant low? Is that the real reason? That's probably the most common cause. I don't know. I don't know what to tell you. So I did the best I could. I hope you enjoyed the video. I hope it gave you some idea or some direction if you're having this problem. And don't forget to check out some of my other repair videos right here on YouTube. Thanks for stopping by. I appreciate your time, and I'll see you on the next one. Take it easy. All right, let's find out what that abnormal noise is. What'd you say? It sounded like a ribbit?
Like a toad.
There you go. What's that down here? Can you zoom in on
There
that?
it goes.
Let me see. I'm going to touch him. I'm going to see if he moves. You got it?
Yeah, I got it. It's Kermit. He was looking for Miss Piggy. He's alive.
He's alive. How do we get him out?
Boy, this is like surgery. Steady hand.
He's probably, oop.
We're trying to get you out, Kermit.
Yeah, I don't want to hurt him. Oh, shoot. He's like blowing up. Look.
Let's see.
I want to grab that foot. He's getting upset. Oh, shoot. He just hopped over. Come on, Kermit.
Maybe
Damn
he'll
it.
find his way